there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. The numbers of the universe boggle the human mind.
In the observable part of the universe, there's something like 100 billion galaxies, each with billions of stars.
The Andromeda Galaxy is about 2.5 million light years away.
The Earth is orbiting the Sun at a speed of about 66,000 miles per hour.
Most of us give up even trying to comprehend such titanic sizes, distances, and speeds. But are there ways to bring the sweep of the cosmos down to Earth? To help us understand how big, how far, and how fast. Planet Earth, for all its wide expanses, deep seas, and massive mountains, amounts to a speck of dust when stacked up against the immensity of the cosmos.
The observable universe contains of order 100 billion galaxies, and then each galaxy, like the Milky Way, contains of order 100 billion stars.
The numbers quickly get up into the millions, and then the billions, and even the trillions, and by then we've really lost all sense of what that really means.
The human mind is finely tuned to deal with the scale of day-to-day experience. The brain can understand traveling 50 miles in a day, but what about 500,000? And a person may know what it's like to move at 100 miles per hour. But what about 100 million?
Numbers like millions and billions and certainly trillions are very hard for most people to imagine because, frankly, most of us don't have billions or trillions of anything.
So how can we ever know the universe if our brains can't really comprehend its massive scale?
Doing scale models of objects in the universe is really helpful because it brings them down to sizes that we can imagine, that we do see in our normal everyday lives.
We can start by cutting the biggest players of the night sky, planets, stars, and galaxies, down to an earthly scale. There are two ways to evaluate size. We can measure dimensions, meaning height, length, and width, or calculate bulk, also known as mass. Bigger doesn't always mean more massive.
Let's say a balloon has the same volume as a bowling ball, but the bowling ball has more mass because it's denser. It's just got more mass crammed into that same volume.
To help get a grasp on some of the immense masses floating around our universe, astronomer Laura Danley visits a monster truck rally, a place where objects of hugely differing masses often collide.
We've got everything from a small toy truck to the giant monster truck. And that gives us a range of mass that will help us understand how massive things are in our solar system compared to each other and how massive our own sun is compared to some other stars.
We begin the comparison with Jupiter, known as the king of planets, and for good reason. Its mass amounts to more than 4 octillion pounds. That's a 4, followed by 27 zeros. Put another way, it would take more than 300 Earths to match Jupiter's mass. But even that is measly when compared to the Sun.
The sun is by far the most massive thing in our solar system. It's about 1,000 times more massive than Jupiter, the biggest planet. Well, by comparison, this car behind me is about 3,000 pounds, and this little toy truck is about 3 pounds. So that's about the same difference between the Sun and Jupiter.
It's a crushing difference, as 3,000 pounds make perfectly clear. But remember, this is a monster truck rally, and the junk car representing our Sun may regret picking on little Jupiter.
The Sun is the most massive object in our solar system, but it's not the most massive star in the galaxy. There are a lot of stars more massive than the Sun.
To envision the disparity between the Sun and a more massive star, let's keep the 3,000-pound junk car as the Sun and put it up against a 10,000-pound monster truck, representing a star some 75 light-years away.
The difference between the monster truck and the car is about the same difference as a star called